The darkness between the stars is not empty. It is only light that has not arrived yet. There is an edge to the universe you can see, and tonight you sit at its exact center. So does everyone else in every direction at once. The edge is not a wall, and nothing waits there to stop you. It is only the time light has had to travel, nearly 13.8 billion years. Whatever lies beyond it is not missing, its light has simply not reached you yet. For the next 2 hours we drift out toward that boundary and rest in the quiet fact that we may never know what lies beyond. Tonight, begin with the darkness rather than with the stars. The black spaces between the points of light are the part that almost nobody bothers to look at. They seem like nothing at all, like the plain background against which the bright things have been arranged. That darkness is one of the oldest and quietest clues we have about the age of everything. From the time of Newton onward, many thoughtful people assumed the universe simply went on forever. Stars scattered endlessly through endless space, with no border, no final star, no far wall waiting at the end. It felt like the modest assumption, the one that did not place us anywhere special or make the world small. But if you take that picture seriously, even for a few minutes, the night sky becomes impossible. Think of standing inside a forest that has no edge, its trees scattered evenly in every direction, going on without limit. Look along any line you like, straight ahead, a little to the left, slightly upward. Sooner or later that line meets a trunk, because the forest never runs out of trees to put in the way. You simply cannot see out of an endless forest. Every direction ends in bark. Now set stars where the trees were standing. In a universe that is infinite and unchanging and filled evenly with stars, every line you look along must end on the surface of some star. Not merely most of them, but every single line in every direction, with no gap left anywhere for darkness to sit in. The whole sky should burn with the brightness of a stellar surface at midnight in every season, in every year of your life. The obvious objection to all of this is distance. Faraway stars look faint, and surely their light thins away to nothing long before it can reach you. That is true of any single star whose light weakens with the square of its distance from you. But the arithmetic quietly betrays you, because the number of stars grows in exactly the same proportion. Consider a thin shell of space at some chosen distance, wrapped all the way around you like the skin of a bubble. Push that shell twice as far away, and each star inside it delivers only 1/4 as much light. The shell now has 4 times the surface area, so it holds 4 times as many stars. The two effects cancel each other with an almost rude precision. Every shell, near or far, sends you the same quantity of light. Add together an endless number of shells, each one contributing the same amount, and the total is endless as well. The sky would not merely be bright. It would be white, and even in every direction you could ever turn your face, with no dark place left anywhere in it. Yet here you are, lying in the dark, able to see the dark. The night is black between the stars, and it has been black on every night of your life and every night before you. Something in that neat picture of an infinite, eternal, unchanging universe has to be wrong. The darkness itself is the evidence. The puzzle is an old one, and it has passed through many careful hands. Kepler turned it over, and Halley after him, and a Swiss astronomer named de Chasseau, and finally a German physician and astronomer named Heinrich Olbers, whose name it usually carries now. Some propose that clouds of dust between the stars were quietly blocking the light of the far ones. That answer fails, and it fails in a rather beautiful way. Dust that absorbs starlight for long enough grows warm, and warm dust glows, and in time it would shine as brightly as whatever it had been hiding. You cannot store an unlimited amount of light behind a screen. It has to come out somewhere. The real answer is gentler than any wall or curtain, and it is the reason you're lying here tonight. The universe is not eternal in the way that argument quietly assumed. There is a finite amount of time behind us, and light does not travel instantly, and so only a finite number of stars have ever had the chance to send their light this far. Most of your lines of sight do not end on a star at all. They simply run out of time before they find one. Stars are not everlasting either, burning for millions or billions of years rather than forever, which thins the sum a little further. The expansion of space also stretches the light of the most distant sources, draining away some of its energy on the journey. The largest reason, though, is the simplest one. The universe has not been here long enough to fill its own sky. So the darkness above you is not emptiness, and it is not a shortage of things that shine. It is a record of how much time light has had to travel. Every dark patch you can find between the familiar constellations is a direction in which something may well exist, sending its light patiently toward you, still traveling, not yet arrived. The night sky is not a finished picture. It is a slow delivery, still in progress, and you happen to be awake in the middle of it, which leaves one quiet question to carry with you toward sleep. If light needs time to arrive, then nothing you have ever seen was truly happening at the moment you saw it. Let that settle for a while, softly, without hurry. We will follow it out into the dark. Light is quick enough to feel instant and slow enough to change everything. It crosses a room before you can register that a lamp has been switched on. It also takes years to reach the nearest star, and millions of years to reach the nearest large galaxy. Every one of those journeys costs time, and the cost is never refunded. Through empty space, light travels at close to 300,000 kilometers in every single second. Nothing carrying information has ever been measured moving faster, and as far as anyone can tell, nothing ever will. That figure is not a rule imposed on light from somewhere outside. It is closer to a property of space and time themselves, and light simply happens to run at it. Because the speed is finite, seeing is always a form of remembering. The lamp on the far side of your room reaches your eyes in a few billionths of a second, so your view of the room is already faintly out of date. That delay is far too small for you to notice, and no sense you have could ever catch it. But it does not vanish merely because it is small. It only grows as you look further out. The moon is a little more than 1 second away from you. The face of it hanging in your window tonight is the face it wore a moment ago, not the face it wears now. The sun is about 8 minutes and 20 seconds away. If it were somehow to go dark, you would carry on in ordinary daylight for those 8 minutes, feeling nothing unusual, entirely unaware. Jupiter sits between about 30 and 50 minutes away, depending on where the two of you are in your orbit. Neptune is roughly 4 hours away. Without leaving the familiar family of planets, you are already looking at an evening that is not one single moment. Each object shows you a slightly different past, and all of those pasts arrive together in the same glance. Beyond the planets, the delays stop being minutes and start being years. The nearest star to our Sun is Proxima Centauri, and its light needs 4.24 years to reach you. When you look toward it, you are seeing it as it was 4 years ago. Any change it has undergone since then is simply not available to you and will not be for years yet. A light year sounds like a stretch of time, and the phrase misleads almost everyone at first. It is in fact a distance, the distance light covers in 1 year, roughly 9.5 trillion kilometers. The word year sits inside it because out here, distance and duration are the same currency. Andromeda is the furthest thing most people can see without any instrument, a faint smudge on a very dark night. Its light has been traveling toward you for about 2.5 million years. It set out when the first stone tools were being shaped on the African plains by ancestors who were not quite us. You're not really looking at a galaxy. You are looking at a message about a galaxy, written long ago and only now delivered. Telescopes are usually described as instruments for seeing further away. They are, but the more interesting description is that they are instruments for seeing earlier. Every gain in depth is a gain in age. When a large telescope gathers the light of a galaxy far across the sky, it collects a portrait of that galaxy as a young thing, still assembling itself, still forming its earliest generations of stars. What such a galaxy looks like at this exact instant is not something anyone can photograph. That image is still in transit, and it will remain in transit for billions of years, long after anyone who wanted it is gone. The present tense at cosmic distances is not something you can observe. It is only something you can assume. Cosmologists do keep a kind of shared clock, a careful way of saying how old the universe is at any given place within it. But that clock is bookkeeping rather than eyesight. Nobody can check the present moment of a distant galaxy or send a message to hurry the answer along. All you can ever do is receive what has already been sent and read the date that distance has stamped into it. So when you look out into the night, you're not really looking across a space. You are looking down a long corridor of time, and the far end of it is younger than the near end. The deeper you go, the earlier things become, and the earlier they become, the stranger and rougher and less finished they appear. Push along that corridor far enough, and the galaxies grow small and unfamiliar and far less settled than the ones nearby. Push a little further and you arrive in an era before galaxies had gathered themselves together at all. Further again, and there were no stars anywhere in existence, nothing burning, nothing shining, nothing for any eye to catch. And yet even that period is not truly dark to us. There is light from it, older than every star that has ever formed, still arriving here tonight, still faintly warming the sky in a color your eyes were never built to see. That light is where we are going next. For now, let the delay feel restful rather than lonely. Everything you looked at today was a little older than it seemed, including the faces you love, and nothing at all was lost in the waiting. The universe simply takes its time to reach you, and it has never once failed to arrive. The oldest thing you will ever see is not a star, and it is not a galaxy. It is a faint and even glow that fills the sky in every direction, far too cold and far too quiet for your eyes to notice. It was already ancient before the first star had finished gathering itself together. Tonight it is still arriving, passing through the roof, passing through the room, passing through you without a sound. For its first few 100,000 years, the universe was too hot to be clear. Space was filled with a dense fog of bare atomic nuclei and loose electrons, and light could not move through it in a straight line. A photon would cross a tiny distance, strike a free electron, and be thrown off in some new direction. Light existed everywhere, and yet it went nowhere at all. Everything glowed and nothing at all could be seen. Then the fog began to cool. As space expanded, that heat spread thinner and thinner, the way warmth fades from a room whose walls keep drawing further apart. After roughly 380,000 years, the temperature fell low enough for electrons to settle around nuclei and stay there. The first complete atoms formed, quietly, everywhere at once. The loose electrons that had been batting light in all directions were suddenly bound up inside hydrogen and helium, and the fog cleared. The light that had been trapped for all those thousands of years was set free to travel. It did not come from one place. It came from every point in space at the same moment, and it left in every direction, and a small part of it has been in flight ever since. Some of that light has been traveling for 13.8 billion years, and it is only reaching you now. When it began, this light was not faint. It was the deep, warm orange of glowing metal, and it filled everything there was. Standing inside that moment, you would have found no darkness anywhere to look at, no shadow, and no direction that was not shining. What happened next was not a fading. As space stretched, the waves of that light stretched with it, their crests drawn slowly further apart. Orange slid into red, red slid down into the infrared, and the infrared slid further still into microwaves too long and too gentle for any eye. The glow did not burn out, and it did not grow tired. It cooled because the space it was crossing kept opening. Today, that ancient light sits a little under 3 degrees above absolute zero. It is colder than anything you would find anywhere on this planet without a laboratory and a great deal of effort. And it is the temperature of the sky itself in every direction you could ever point. It is the leftover warmth of a universe that was once a furnace, spread so thin that it barely registers at all. The name given to it is plain and a little disappointing: the cosmic microwave background. It sounds like a piece of equipment or a setting on a dial rather than the last visible breath of the early universe. In the middle of the 1960s, 2 radio astronomers in New Jersey kept finding a faint hiss in their antenna that they could not remove. They checked the wiring and they cooled their instruments. They evicted a pair of nesting pigeons and cleaned out the mess the birds had left behind. The hiss stayed steady and even by day and by night, in every season from every part of the sky. It was not a fault in the equipment. It was the fog lifting, 13.8 billion years ago, still arriving. For decades afterwards, a small share of the gray snow on an untuned TV screen was that same light landing in an ordinary living room. The glow is not perfectly smooth. Some patches are very slightly warmer than others, and some very slightly cooler by roughly 1 part in 100,000. Those faint differences are the beginnings of everything that ever took a shape. The slightly denser regions pulled a little harder, gathered a little more, and became, over very long ages, the galaxies and the stars and the quiet planets. A map of that glow is a portrait of the universe before anything in it had yet been built. Because that light was released everywhere at once, you do not see it lying in one direction like an object. You see it as a shell surrounding you at whatever distance its light has managed to cover since the fog lifted. It is not a wall, and it is not the surface of anything solid. It is a moment in time, seen from very far away. You cannot look past it with light, and not because anything is standing in the way now. Before that moment, light was tangled in the fog and could not carry a picture of anything at all. The oldest light there marks the earliest scene that light itself will ever be able to show you. So the sky you are sleeping under is not empty, and it is not quite silent either. It is glowing very faintly, at a temperature just above nothing, in a shade that sits well outside what any eye can register. How far away that shell of ancient light lies, and what it means to speak of an edge at all, is where we drift next. For now it is enough that it keeps falling on the roof, weightless, older than anything else that will touch this house tonight. There is a distance beyond which you cannot see, and it has nothing to do with your eyes or with telescopes or with anything that could be built better. It comes from a much simpler fact that light takes time to arrive, and that there has only ever been so much time. Everything whose light has had long enough to reach you lies inside one sphere. Everything else lies outside it, for now. That sphere is called the observable universe, and the name is more careful than it first sounds. It does not describe a region of space with a boundary of its own. It describes how much of the universe has had the chance to send you a message. It is a sphere drawn not by walls but by patience, by how long there has been for light to move. Its radius measured as things stand tonight is about 46.5 billion light years. From one side of it to the other, that is roughly 93 billion light years. You may already have noticed something strange in that figure because the universe is 13.8 billion years old. Light traveling since the very beginning should have covered 13.8 billion light years and not one step further. The answer to that is real, and it is quiet, and it is waiting for us in the chapter just after this one. Inside that sphere there are galaxies past any hope of counting. Careful estimates run from a few hundred billion up toward 2 trillion, depending on how many small and faint ones you believe are hiding below what our instruments can register. The honest answer is that nobody has counted them, and nobody ever will. The most distant single objects we have found are small young galaxies, whose light set out when the universe was only a few 100 million years old. They arrive as faint red smudges, barely separable from the grain of the detector. Whatever those galaxies grew into happened an extremely long time ago, and the news of it is still out in the dark somewhere, crossing patiently toward us. The word edge does most of the damage here. It suggests a rim, a place you could arrive at, a point where the universe politely stops and something else takes over. There's nothing of that kind out there. If you could stand beside the most distant galaxy you can see tonight, you would find ordinary space around you, ordinary stars, ordinary dust, all of it going about its business. From there, the sky would reach out into regions your own sky has never touched, and it would look in every direction entirely unremarkable. You could not travel to the boundary either, and not because the journey would simply be long. By the time you arrived anywhere near where it seems to lie, it would have moved further out, and it would still be sitting far ahead of you. Nobody could ever reach that place and stand upon it. It marks how much time has passed since there was anything at all to send. The sphere does not stay the same size. Every second, light that's set out from a little further away finishes its journey and arrives here for the first time. Things that lay beyond your sight yesterday can come into it today, quietly, without any announcement being made. The universe does not grow in order to allow this. It is only that light keeps completing journeys. It began a very long time ago. In practice, though, your view stops before it reaches that outer figure. Long before the limit, you run into the ancient fog we sat with a little while ago. The oldest light forms a curtain, and no instrument can lift it, because there was no clear light behind it to be lifted. The material that released that glow now lies about 1 billion light years short of the outer boundary, which in this particular arithmetic counts as almost nothing. Two other messengers could, in principle, carry news from earlier than that curtain. Neutrinos stopped bumping into everything else when the universe was roughly 1 second old, and they have drifted freely ever since. Gravitational waves pass through the fog as though it were not there at all. A background of each is expected on good grounds, and neither has yet been caught directly, though the neutrinos leave clear marks on the oldest light. So a little more of the story exists in principle than anyone has ever managed to hear. None of this means the universe stops where your horizon stops. Everything past it is presumably as ordinary and as crowded as everything inside it, full of galaxies that have never sent you anything you could receive. Their light, in many cases, is simply still in transit, working its way across a gap that keeps widening beneath it. They are not missing from the universe. They are only, for the moment, out of touch with you. An edge made of time is a strange kind of edge. It has no thickness, no fixed address, and nothing at all standing guard along it. It is only the furthest that anything has managed to travel toward you while you and this world were slowly being made. And that figure that seemed not to add up, the one so much larger than the age of everything, does have a reason behind it. It has to do with the growth of space itself, and we follow that road from here, gently with the lights kept low. There is a number in cosmology that sounds on first hearing like an error. The universe has been growing for about 13.8 billion years. Yet the farthest edge of what you can see lies near 46.5 billion light years away in whichever direction you turn. Light moves at one fixed speed and has never moved faster. Nothing should have reached you from beyond 13.8 billion light years. The larger figure looks like something a tired writer forgot to correct before the book went out. It is not a slip of the pen. It is the fingerprint of an expanding universe, and it unfolds slowly, which suits the hour. Begin with a single grain of light. It left a young cloud of hydrogen when everything was much smaller and far hotter than it is tonight. It set out toward the place where you would one day lie, and traveled without pause for more than 13 billion years. While it traveled, the space it was crossing grew, not the light itself which kept its steady pace throughout. The distance from one end of the journey to the other grew. Every stretch of emptiness already behind it became longer, and every stretch still ahead became longer as well. That is the heart of it, though the mind takes a while to settle. The light never went faster than light. It arrived late instead, having crossed a road that lengthened quietly beneath it. And the cloud that released it did not wait politely where it was. It was carried outward by the same growth, so the matter which made that light now rests much further away than the road the light actually walked. 3 different distances hide inside one short phrase about the edge of the visible universe. There is the distance to the source on the night the light departed. There is the length of the path the light truly covered while it was underway. And there is the distance to that same matter tonight at this moment while you lie still. Only the middle one is limited by the age of the universe. The other two are free to be smaller or very much larger. The oldest light of all shows this plainly. When it was set loose, the matter that released it lay only about 40 million light years from the matter that would slowly become the Earth, the oceans, and you. That is a modest gap by cosmic standards, nearer than many galaxy clusters within reach of a decent telescope. Yet that light spent almost the entire life of the universe in transit, because the gap kept opening while it crossed. The matter it left behind has since been carried out to something close to 46 billion light years away. None of this breaks the rule about the speed of light. That rule is a local one. It says that nothing overtakes a light beam in your own neighborhood, where you can lay a ruler down and compare. It says nothing at all about how quickly the separation between two very distant regions may grow. Those far galaxies are not moving outward through space the way loose fragments drift away from a common starting point. They sit quietly in their own patches of space, much as you sit in yours, while the space between grows. Recession in this sense is not really travel. You may wonder how anyone arrives at a figure like 46.5 billion. It is not measured with a tape. It is calculated from a history. The stretching of light from distant exploding stars, the faint pattern printed on the oldest light, and the spacing of galaxies across the sky all record how quickly distances have grown in different eras. Put that history together, and you can ask where the matter that sent us its light must have drifted since. The answer is the number that looked at first like a mistake. It is worth saying honestly that this figure carries uncertainty. Two respected ways of measuring the present rate of expansion still do not quite agree, and that disagreement is one of the open problems of the subject. If it is settled in one direction or the other, the edge may move by a small fraction. But no adjustment of that size could ever close the gap between 13 and 46. The strangeness is real, and it survives every careful check. There is one more thing to hold gently before you drift. The edge you have been circling is not a surface, and no wall stands at 46.5 billion light years with nothing at all behind it. It is a horizon, the ordinary kind, of the sort you meet at sea. It marks only how far the light has managed to come, and it widens as time passes, and things lie beyond it as they always do beyond any line of sight. So the number that looked wrong is really a record of patience. Light kept its promise and never hurried once. Space took its own time and quietly grew, and the two together stretched a 13 billion year journey into a 46 billion light year separation. Nothing cheated the rules, and nothing at all was broken. The universe simply made more room while the messengers were still out on the road. And if the growth of distance can carry matter that far, a question follows, the one almost everyone asks next, usually in the dark. What is all of it growing into? That can wait a little while. Let it rest there, unanswered and untroubling, while the old light keeps arriving steady and unhurried at the small quiet place where you are. The question tends to arrive on its own, late, when the room is dark and the mind has stopped guarding itself. If everything is spreading apart, then what is it spreading into? It feels like the obvious next thing to ask, and nothing about it is foolish. But it is one of those questions built in the wrong shape, and taking it apart is far more restful than answering it would be. The trouble hides in the small word into. Every expansion you have ever watched happened inside something larger. Dough rises in a warm kitchen. A balloon pushes aside the air of the room. Smoke spreads across a ceiling and finds the walls. In each case there is the stuff, and there is the room it occupies, and the two are separate things. Your intuition learned its expansion from those examples, and it learned them well. It has simply never met an expansion that is not happening inside anything at all. Take the surface of a balloon, and only the surface marked all over with small dots. Let the entire world be that thin skin of rubber with nothing else in it. The air inside is not part of that world, and neither is the room around it. As the rubber stretches, every dot moves further from every other dot, and no dot is the source of the spreading. Ask a dot which direction the growth comes from, and it has no answer, because the growth comes from no direction. It happens between things everywhere at once. That picture helps, and it also lies a little, so it is only fair to say where. Our balloon has an inside and an outside because we drew it that way, watching from a room. The mathematics that describes the growing universe never needs that outer room. It works entirely from within, using only distances measured between things that are actually in it. The extra space we imagine around the balloon is a crutch for our eyes, not a claim about what exists. The familiar loaf of raisin bread has the same virtue and the same flaw. As the dough rises, every raisin drifts away from every other, and the more distant raisins part company faster. That much is a decent likeness. But a loaf has a crust, and beyond the crust there is an oven, and beyond the oven a kitchen. The likeness fails at precisely the point your question is aimed. So what is it that actually grows? Not the contents drifting through some fixed and waiting emptiness. What changes is the scale of distance itself. Cosmologists carry a single number telling them how much larger any given separation is now than it was earlier. Almost everything else follows from that one quiet fact. Light that set out long ago is stretched while still in flight, arriving redder and cooler than it left. The gaps between distant galaxies widen year after year. The grand pattern is not a motion so much as a change in the meaning of the word apart. It is worth noticing what takes no part in this. Your body is not being stretched tonight. The earth is not drifting away from the sun in this manner. The galaxy holding every star you can see is bound by its own gravity, and so is the small group of galaxies it belongs to. Where matter has gathered densely enough to hold itself together, it simply holds. Expansion is a statement about the vast average, about the thin spaces between the great islands, not about anything within reach of your hands. There is also no center to point toward. Every observer in every galaxy sees the same pattern of things drifting away, and each might be forgiven for feeling central. There is no special place where it all began pushing outward, because it did not begin at a place. Whatever happened, happened everywhere that existed at the same time. The early universe was not a small bright object sitting alone in the dark. It was a hot, dense condition of everything there was, which is a very different thing. Then what about the far side of the matter? Is there a last galaxy somewhere with true emptiness beyond it? Nothing we have measured points to such a place. Wherever we turn out to the limit of what light has managed to bring us, the universe carries on with more of the same. Whether it carries on without end is a separate question, a deeper one, and it will keep for a later hour. The honest answer to what it is expanding into is not the word nothing, which sounds like a small joke at your expense. The honest answer is that our best description of gravity contains no outside, has never needed one, and no measurement has ever asked for one. Perhaps some larger arena exists and lies forever beyond testing. If so, it makes no difference to anything you could observe, and a claim that cannot be tested is not knowledge. It is only a story worn smooth by repetition. There is a kind of comfort here once the mind stops searching for the wall. Nothing is pushing outward into unknown territory. Nothing is running short of room. The universe is not going anywhere at all. It is only becoming roomier, gently and everywhere at a pace too slow for any single life to feel. And that quiet widening has one consequence worth resting on. Some things that once sent us their light have been carried so far that their newer light will never make the crossing. They are still out there, and they are already beyond our reach. That thought can wait until your breathing has slowed a little further. Somewhere overhead tonight, in no particular direction, sits a small smudge of light that comes from a galaxy you will never be able to reach. Nothing has gone wrong with it. It has not gone dark. It has not been swallowed by anything, and it is very likely still turning quietly through its own long evening. The light you can see left it billions of years ago, and that light is still arriving, still exactly on schedule. What has changed is the space in between. That space has been growing the whole while, and it now grows faster than any new message could ever cross it. Expansion works gently and everywhere at once, adding a small amount of distance to every stretch of empty space in every moment. Close to you, the effect is far too small to matter, and it does nothing at all to the floor beneath you or to the atoms holding your bones together. Gravity and the ordinary forces keep those things exactly as they are. But the further away something sits, the more stretches of open space lie between you and it, and the faster the total gap widens. Past a certain distance, that widening outruns light itself. The distance where this happens is called the Hubble radius, and tonight it sits roughly 14 billion light-years away from you in every direction. Beyond it, galaxies recede from you faster than light travels, though not one of them is hurrying anywhere. They sit calmly in their own neighborhoods, while the room between you and them keeps being made larger. It would be easy to assume that this is the moment a galaxy disappears from you, and the assumption is wrong in a way that repays a little attention. Light from a galaxy already receding faster than light can still reach you eventually, because that boundary is not fixed in place. A photon out there is swimming upstream against a current slightly stronger than it can manage, losing ground steadily. Yet the current itself has been easing for a very long time, as the universe thins out and expansion slows in that particular sense. As it eases, the boundary drifts outward, and a photon that was falling behind can find itself inside a gentler stretch of the river, where it begins to make headway again. Some of the light in your sky tonight did precisely that, and has only just finished the climb. So there is a second boundary, quieter and far more final, and that is the one that decides what is truly gone. If a galaxy sends its light out today from beyond roughly 16 billion light-years, measured in distances as they stand at this moment, that light will never finish its journey to you. It will travel forever, and the space ahead of it will keep opening faster than it can close, and it will still be traveling long after everything that might have received it has gone cold. Past that line, the universe is not hidden from you exactly. It is simply out of correspondence, permanently in a way no patience and no instrument can undo. Most of the galaxies you can see tonight are already on the far side of that line. Of everything inside the sphere you are able to observe, only a small inner portion, a few parts in 100 by volume, remains close enough that a signal sent now could ever arrive. All the rest have already posted their final letters to you. The letters themselves are still in transit, some of them for billions of years yet, and you will go on receiving them long after nothing new can be sent. And here is the strange gentleness of it. Nothing in the sky ever blinks out. A galaxy crossing that last boundary does not vanish from view. It only begins to slow down in front of you. The light it sends from later and later moments takes longer and longer to arrive, so the image you receive drifts toward a standstill, holding one final pose. Its colors slide downward from visible light into infrared, then into wavelengths so long and so faint that no instrument could ever gather enough of them to form a picture. What remains is a portrait of it, frozen at the last moment it was able to speak to you, growing dimmer for the rest of time without ever quite reaching zero. Somewhere out there, if anything is looking back this way, your own galaxy is doing exactly the same slow fading in their sky. Neither of you would notice the moment it happened. There was no crossing, no sound, no line drawn on anything. There was only a night much like this one on both sides, with the light still arriving as usual. There is nothing troubling in any of this, and nothing is being lost. The galaxies already gone are still out there, still forming stars, still entirely unbothered by the fact that they and you have stopped being able to reach one another. What ends is not them, only the conversation between you. And the ending is not sudden, it is the softest kind of goodbye, spread out across more time than the universe has yet lived. Rest with that for a moment, if you would like, the idea of a farewell so slow that it looks exactly like a still photograph. The sky above your roof is full of them, and it will look almost unchanged tomorrow night, and almost unchanged 1,000,000 years from now. Only much later does the loss become something you could see, and that far future sky is where the story turns now. Expansion has not always been speeding up. For most of the history of the universe, it was slowing, gently and steadily, the way you would expect from a room full of matter pulling on itself. Then, somewhere around 5 billion years ago, the matter had thinned out enough that something quieter began to take over. Astronomers found this by watching a particular kind of exploding star, the sort whose true brightness is understood well enough to serve as a measuring rod. The distant ones came back fainter than they should have been, which meant they were further away than a slowing universe could account for. Space was not simply growing. It was growing a little more eagerly with every passing age. The cause is called dark energy, and that name is an honest placeholder for something we do not understand. It behaves like a property of empty space itself, a faint and even pressure that does not weaken as the volume increases. Matter thins as the universe grows, so its pull fades, while this does not thin at all. Given enough time, the thing that never fades wins by patience alone. That is the whole story of the far future in one line, and everything that follows is only the working out of it. If dark energy stays exactly as it appears to be, the shape of the coming ages can be described with some confidence. Gravity keeps whatever it has already gathered. Your galaxy and its close companions are bound together tightly enough that no amount of expansion will pull them apart. Andromeda is drifting toward you rather than away, one of the very few large things in the universe still approaching. In roughly 4 or 5 billion years, the two galaxies may well meet, pass through one another, and settle slowly into a single rounded island of older stars. Recent work makes that meeting likely rather than certain, since the sideways motion of Andromeda is still poorly pinned down. The smaller companions will fold in over time as well. That island will be the whole of your inheritance. Everything beyond it is on the far side of the tide. The great cluster of galaxies in the direction of Virgo, which your neighborhood has been slowly falling toward, will very likely never be reached. The pull is real, but the widening between you is winning, and the gap will keep opening. Over the next tens of billions of years, those galaxies and all the others will drift outward, redden, slow in your view, and fade. One by one, quietly, without any event to mark it, the sky empties. The end of that process is a strange and simple place. Something like 100 billion years from now, an observer living in that merged island of stars would look outward and find nothing. No other galaxies, no faint smudges, nothing beyond their own crowd of suns and the dark between them. The oldest light, the glow left over from the beginning, would still be there in principle, but stretched so far that its waves would be longer than any reasonable instrument could catch. The evidence of a beginning would not have been destroyed. It would only have been stretched beyond reading. Astronomers born into that sky could be careful, honest, and clever, and they would still conclude that they lived in one solitary island of stars in a static and unchanging void. They would have no galaxies to measure a redshift against, and no leftover glow to hint at a hotter past. Nothing in their sky would suggest that space grows. They would be wrong, and there would be no way for them to know it, and no fault in their reasoning at all. It is worth holding that thought gently before you sleep. The evidence for how everything began is lying openly around us now, in a window of time that will not stay open forever. There is one honest uncertainty to place beside all of this. Recent surveys have hinted that dark energy may not be perfectly constant, that it may have been slightly stronger in the past and could be easing now. Those hints are not yet strong enough to be called a finding, and they may soften away as better measurements arrive. If they hold, the far future takes another shape entirely, perhaps gentler, perhaps stranger. So the loneliness described here is the most likely story rather than a settled one, and even the ending of everything is something we are still in the middle of learning. None of this is anything you need to carry with you tonight. The numbers involved are so large that they stop meaning very much, and every one of these losses is spread across more time than life on this planet has yet existed. Nothing about your sky is changing in any way you could notice, or that anyone will notice for an unimaginable stretch of nights. The neighbors overhead are the same ones your ancestors saw, and they will be the same for your descendants for longer than the species is likely to last. And if you want one small thing to rest on, take Andromeda. It is up there most of the year, a faint oval smudge you can just about see with your own eyes from a dark enough place 2.5 million years of travel behind it. It is coming closer with every passing year. In a universe slowly spreading itself thin, something is still on its way toward you, and it always was. The sky is not empty yet. It is crowded and lit and still full of questions large enough to hold, including the oldest one of all, which is what shape the whole thing takes. We come to that question now softly, with no need to hurry. Space has a shape, and that shape can be measured, though not with any ruler you could hold in your hands. It is one of the quieter achievements of the last 100 years that the geometry of everything became a question someone could go and check. For almost all of human history, the rules of geometry were simply assumed to be true. Parallel lines never met, and the three angles of a triangle always added to the same steady total, and nobody thought to ask why that should be so anywhere forever. Then mathematicians found that other geometries were possible, entirely consistent ones, in which those familiar rules quietly fail. Once that door was open, the shape of our own space stopped being an assumption and became something a person could try to measure. There are three broad possibilities, and they are gentler to hold in mind than they sound. Space may be flat, in which case two beams of light sent out side by side stay side by side forever. Space may curve one way, closing softly back on itself, so that those two beams lean slowly toward each other across enormous distances. Or space may curve the other way, opening outward as it goes, so the beams drift apart faster than you would expect. Space is not bent inside some larger room, and no such room is needed anywhere in this account. The curvature is measured entirely from within, by the behavior of light and distance and angle, and it needs nothing outside itself to bend into. A large enough triangle is all you require to tell which of the three cases you're living in. If the angles of that triangle add to slightly more than they should, space curves one way. If they fall slightly short, it curves the other. The trouble is that curvature, if there is any at all, is slight, and a small triangle cannot reveal it. There is a story, probably tidied up in the retelling, that one of the mathematicians who opened this door surveyed lines between distant mountain peaks to see whether the angles came out wrong. Nothing showed, which is what so small a triangle would be expected to give. To catch a curvature this gentle you would need a triangle with sides long enough to cross a serious fraction of everything visible. That sounded impossible for a long time, and then the oldest light handed us one for nothing. The faint glow left over from the young universe is not perfectly smooth. It carries a pattern of slightly warmer and slightly cooler patches, and those patches have a preferred size. That size was set by sound. Before the universe turned clear, it was a hot, dense fog, and pressure waves ran through that fog much as sound runs through air. Those waves could travel only so far before the fog lifted and the sound stopped, and that distance can be worked out from ordinary physics. It is stamped across the sky as a favored patch width, the same wherever you look. So you have a length, you know, printed on the sky, sitting at a distance you also know. Those two facts give you the base of a triangle, with its long sides running from your eyes out to that ancient light. All that remains is to measure how wide the base looks from here. If space is flat, it should look about 1 degree across, roughly twice the width of the full moon. If space curved one way, the patches would be magnified and appear larger than that. If it curved the other way, they would be shrunk and appear smaller. The measurement has now been made many times by instruments carried on balloons above the polar ice and by telescopes in orbit. The patches come in almost exactly the size that flat space predicts. As far as anyone can tell, the geometry of the universe is flat to within a small fraction of 1%. That result is worth sitting with for a moment because it is not the same as saying space is exactly flat. No measurement ever returns the word exactly. Every measurement has a width to it, and any curvature gentler than that width would simply hide inside the uncertainty, unseen and undisturbed. What flatness really gives you is a minimum size rather than a final answer. If space curves at all, it curves so gently that everything you can see is a small smooth patch of something enormously larger, in the way a single field can seem level on a round world. there is also a puzzle folded into the answer. The flat case is a knife edge. A universe born with even slightly too much or slightly too little in it would have drifted far from flatness by now, and yet ours has stayed balanced for nearly 14 billion years. Something appears to have smoothed and stretched the early universe until any curvature it once had was pulled almost entirely out of it. That is a story for later tonight, and it does not need you awake for it. For now, the honest description of the space around your bed is this. It is flat as far as anyone can measure, possibly flat entirely, possibly curved on a scale far too vast to catch. Light in this room travels in straight lines and will keep on doing so, carried by a shape as calm as it appears. Which leaves one more question waiting at the far side of all that flatness, patient and harder than it looks. If space continues this smoothly and this evenly in every direction, does it continue without end? That question waits just ahead, and we take it slowly with no particular need to arrive. There is a question that sounds as though it ought to have an answer by now, and after a century of very careful work, it still does not have one. You can ask whether space goes on forever. Nobody knows, and the reasons nobody knows turn out to be more interesting than either answer would have been. The question is not about the part you can see. That part has a measured width set by how far light has been able to travel. The question is about all of space, including everything beyond the reach of any light that has had time to arrive here. Flatness makes an endless universe easy to hold in mind, because flat space has no natural way of closing back on itself. But flat and endless are not the same statement, and the distance between them is where the honesty of this subject lives. Geometry tells you how space behaves in any small region, and how straight lines behave as they travel through it. It does not tell you how the whole thing is joined together. A flat space can still be finite if it wraps around. There are old screen games in which a ship that leaves the right edge slides quietly back into view on the left. That screen is perfectly flat everywhere, with no curvature at any point on it, and yet it has a finite area and no edge whatsoever. Space could in principle be built the same way, in 3 directions rather than 2, flat under every local test, and still closed and finite overall. Such a universe would have no wall and no outside, only a quiet tendency to bring a traveler back around to where the journey began. That version can be tested, at least in part, which is a small mercy. If space wrapped on a scale small enough to fit inside the region we can see, then light would have crossed the whole of it more than once. The same patch of early glow would then appear in 2 different directions at once, drawn on the sky as matching rings of warmth and cold. Astronomers have combed the entire sky for those matching rings, carefully several times over, and they have found none. That does not prove space is endless. It proves only that if space wraps at all, it wraps on a scale at least as large as everything we can observe, and very likely a great deal larger. The searches place that floor at roughly the width of the visible region itself, and separate arguments from flatness push it considerably higher. A floor is all a measurement of this kind can ever give you. This is the shape of the whole problem, and it is worth saying slowly. You can always show that space is at least a certain size by failing to find its far side. You can never show that it has no far side at all, because the absence of a boundary looks precisely the same as a boundary placed further out than you can reach. Infinity leaves behind no fingerprint of its own. Every observation you could make in an endless universe would look identical in one that is merely unimaginably large. So two answers remain standing, and both are respectable, and neither can be swept aside. Space may be finite and unbounded, folded in some way no observer could detect from inside a single visible patch. Or space may simply continue, galaxy after galaxy after galaxy, in every direction, with no total and no last one. The evidence we have does not choose between them, and it may never be able to. If the second answer happens to be true, and if matter really is arranged out there much as it is arranged here, then a strange consequence follows. With unlimited room, and only so many ways to arrange the contents of a given volume, arrangements would have to repeat somewhere. Far beyond any possible contact there would be another world, another quiet room, another version of this exact moment. That idea is often repeated as though it were established, and it is not. It rests on assumptions about the endlessness of space and the sameness of its contents that cannot be checked from where we sit. It is better held loosely as one possibility among others, in the way you hold most things just before sleep. There is no shame in a question staying open like this. Whether everything is finite may be one of the few facts that remains permanently out of reach, not through any carelessness on our part, but because the evidence would have to come from a place evidence cannot travel from. We are simply standing at the sensible limit of what asking can do. What you are left with is a measured floor beneath an unmeasured height. Space is at least this large and possibly larger without limit, and both of those descriptions leave your room exactly as it is. The stars outside are no nearer and no further for the answer. Nothing about the size of everything reaches down to change the temperature of the air or the weight of the blanket over you. Beneath all of it sits one more assumption, so quiet that it is easy to walk past. Everything we have said about the unseen parts of space assumes that they resemble the parts we can see. That assumption has a name, and it has been tested rather more carefully than you might expect, and it is what follows now. For tonight it is enough to rest inside the not knowing, which is roomier than an answer, and considerably softer. Underneath everything you have heard so far tonight lies a quiet assumption, and it is worth saying out loud. The assumption is that you are not standing anywhere special. Not this street, not this planet, not this galaxy, not this particular pocket of space. Astronomers call it the cosmological principle, and it is less a discovery than a posture before the sky. It says that the universe looks the same everywhere, and the same in every direction, once you step back far enough. That final phrase is doing almost all of the work, and it is the part most often forgotten. Up close, the universe is obviously not the same everywhere. Your room holds more matter than the empty air above the roof. The sun is a dense knot of hydrogen in an otherwise thin neighborhood of gas and dust. Galaxies gather into groups, groups gather into clusters, and clusters string themselves along filaments that stretch for hundreds of millions of light years. Between the filaments lie voids, rounded emptinesses where almost nothing shines. Seen at that scale, the cosmos looks less like a smooth fluid and more like foam, or like the inside of a sponge held up to a window. So the principle cannot mean that every box of space contains the same thing. If you draw a box a few 100 million light years on a side, and then draw another box somewhere else entirely, the two will hold about the same amount of matter. Below that size, structure dominates, and every region has a character of its own. Above it, the differences begin to average away, and the universe settles into a kind of sameness. Astronomers sometimes call that transition the end of greatness, because beyond it nothing larger stands out. The evidence comes from patient counting rather than from any single revelation. Surveys have measured the positions and distances of millions of galaxies across broad sections of the sky. When those maps are sliced and compared, the density of galaxies in one wide direction matches the density in another to within a few parts in 100. The ancient glow that fills the sky agrees even more closely than the galaxies do. Its temperature is the same everywhere to about 1 part in 100,000, a smoothness with almost no parallel anywhere in nature. There is one exception to that evenness, and it is our own fault. Half of the sky is very slightly warmer than the other half by roughly 1 part in 1,000. That warmth is not a property of the universe at all. It is the signature of our own motion. The solar system is drifting through the old light at something like 370 kilometers every second, and the light ahead of us piles up a little. Once that motion is subtracted, the sky flattens back into its quiet evenness. Now comes the honest part, the part that is easy to skip past. What the measurements actually show is that the universe looks the same in every direction from here. That is a statement about one vantage point, and the vantage point is yours. Sameness from place to place is a different claim, and no telescope has ever confirmed it directly, because you cannot stand in two places at once. The bridge between the two is the assumption that your position is ordinary. If the sky looks even from here, and if here is nothing special, then it must look even from anywhere, and a universe like that is the same everywhere. So the principle rests in the end on a refusal to flatter ourselves. It can be tested in pieces, and it has survived every test so far, but it is not a theorem. It is a well-behaved guess that keeps being rewarded. There are complications, and it would be dishonest to leave them out of the story. Occasionally, a survey turns up a structure that seems too large to belong in a smooth universe. Long chains of distant quasars or unusual groupings of faraway explosions have been reported spanning billions of light years. Whether these are true structures or patterns that the eye and the statistics find in sparse scattered data is still argued over. What the principle gives you, if it holds, is a strange and gentle kind of company. Every galaxy you can see is surrounded by the same faint background warmth and the same thinning crowd of distant neighbors. If you were somewhere else tonight, unimaginably far away, the sky above you would not be more crowded or more empty. It would be another version of this one, with different stars and different arrangements, and the same overall grain. The physics would be unchanged as well, which is a separate claim and an even bolder one. The same atoms, the same light, the same slow arithmetic of gravity, working the same way at every address. Distant spectra support this in detail, since hydrogen lit up 10 billion years ago shows the same pattern of lines, merely stretched by the journey. So the universe is not merely similar out there, it is built from the same materials under the same rules. There is something restful in that if you let it settle. No center to search for, no favored room, no address that matters more than any other. Only the same soft arrangement of matter and light, repeating without repeating in every direction you could ever face. And yet the sky is not perfectly even, and the small departures are the most interesting things in it. One of them sits low in the southern sky, quietly refusing to explain itself. In the southern sky, in the direction of the constellation Eridanus, there is a patch of ancient light that is colder than it ought to be. It was noticed about 20 years ago, measured since by 2 separate space telescopes, and nobody has settled what it is. Astronomers call it the cold spot, and it is one of the few genuine loose threads in modern cosmology. To understand why it is odd, you need to know what the sky is supposed to look like. The oldest light is not perfectly uniform. It carries a faint mottling, patches slightly warmer and slightly cooler than average, differing by tens of millionths of a degree. No single patch means anything on its own, but the distribution of their sizes carries a great deal of information. Cosmologists know in fine statistical detail how many cold patches of each size the sky ought to contain. The cold spot is a patch the statistics did not expect. It spans roughly 5 degrees of sky, some 10 times the width of the full moon. At its center, it runs about 70 millionths of a degree below the average, and it is ringed by a faintly warmer border. The combination, a cold region, both this deep and this wide, is rare in the simulated skies that theory produces. How rare is a matter of long argument. Estimates run from about 1 sky in 100 to something considerably less impressive. The difficulty is that the spot was noticed first and questioned afterwards. In a sky full of random features, something will always be the most unusual thing in it, and finding that thing does not make it meaningful. Still, the spot has resisted the simplest dismissals. It appeared in the first detailed maps, and then appeared again in the same place and the same shape when a later and more sensitive telescope remapped the whole sky. Whatever it is, the light really does arrive that way. The most popular physical explanation involves something between us and the glow, rather than the glow itself. Surveys of galaxies in that direction have found a region that seems unusually empty, a vast underdensity sometimes called a supervoid. Light passing through such a place can lose a small amount of energy because the void is stretching while the light is crossing it. The light falls into a shallow valley of gravity, and by the time it climbs out, the valley has widened, so it does not recover everything it gave up. The trouble is one of simple arithmetic. When the size of the void is measured and the cooling is calculated, the effect comes out something like 10 times too small. Later surveys have also questioned whether a void of the required scale lies there at all. So the void may be real and still not be the answer. Beyond that, the explanations become speculative, and they deserve to be labeled as such. Some have suggested the spot is a bruise, the mark left where our region of space brushed against another during its earliest moments. That idea is not impossible, but it currently rests on no independent evidence, and the specific patterns it predicts have not been found. Others suspect a subtle problem in the way foreground light from our own galaxy is removed from the maps. The truthful summary is that the cold spot might be a hint, and it might be nothing at all, and at present nobody can tell you which. It is also not alone up there. The old light holds a small collection of features that sit slightly outside expectation, and together they are known as the anomalies. The very largest ripples, the ones that span the whole sky, are weaker than the standard picture predicts. Two of those broad patterns also appear to line up with one another, and their alignment falls near the plane in which the planets orbit. That is either a coincidence or a sign that something local has leaked into the maps, since the planets cannot have shaped light released long before the Earth existed. Each of these is marginal on its own, and the sky offers no second copy to check them against. That is the deep frustration of this particular science. You cannot rerun the experiment, and you cannot obtain another sky, so a rare coincidence can never be resolved by simple repetition. There is one more unsettled thing, and it was mentioned in passing earlier tonight. The two ways of measuring how quickly the universe expands today still do not agree with each other. One reads the rate from the ancient light, the other from exploding stars in nearby galaxies, and the two answers differ by several parts in 100. The measurements have become precise enough that the gap no longer fits comfortably inside the errors. It may yet dissolve into some overlooked effect, or it may be the first visible crack in a picture that is held for a quarter of a century. Nobody knows, and the not knowing is not a failure. It is only where the work currently stands. There is a comfort in unfinished things if you are willing to accept it. Every one of these puzzles will still be there in the morning, unmoved by whether you thought about it tonight. Some will quietly dissolve into dust or into chance, and one or two may turn out to be traces of something nobody has imagined yet. If any of them survives, it will be because something outside our own sphere left a faint mark on the light we can see. That possibility is worth carrying softly into the dark, and it is the ground we cross next. The question of what lies past your horizon is the one the universe answers most quietly. Nothing about that boundary is a barrier, and nothing about it belongs to the universe itself. It belongs to you, and to the amount of time light has had to travel toward the place where you are. So the first answer to the question is the plainest one available, and it is very probably true. More universe lies out there, and it almost certainly looks a great deal like this. Galaxies in long, faint chains, wide, dark voids lying between them, the same cold background glow filling every gap. We think so not because anyone has seen it, but because the far edge of your sphere shows no sign of being an edge. The most distant regions we can measure resemble the nearest ones, only younger, and they show no thinning and no fading. A real shoreline would announce itself long before you reached it, with shallows and a change in the light. Nothing in the measurements announces a shoreline, so the simplest reading is that the material continues. How far it continues, nobody knows, and the honest range of possible answers is enormous. Some models make the smooth region beyond your horizon larger than the visible part by a factor too big to write down comfortably. Others allow it to be endless, and that is a question of its own. There is a second answer, stranger and far less certain, and it reaches back into the first fraction of a second. To explain why space is so smooth and so very nearly flat, cosmologists propose an early episode of violent stretching, finished before the universe was a trillionth of a second old. That episode is called inflation, and the evidence for something like it is indirect, broad, and taken seriously. It would have taken a region far smaller than an atom and drawn it out to cosmic size, ironing the wrinkles flat as it went. Here is the awkward part of the idea. In many versions of the mathematics, inflation is easy to begin and very difficult to stop everywhere at once. It ends in patches, and not all at the same moment. In one patch, the stretching slows, the stored energy pours out into matter and light, and something like our universe settles into the calm. All around that patch, space may still be inflating, carrying its own edges away faster than anything inside could ever follow. Other patches settle later and later again, and nothing in the equations calls for a final one. This picture is called eternal inflation, and it yields not one universe, but a growing crowd of quiet regions, each sealed inside the stretching. Every region would have its own horizon, its own oldest light, its own sky ending in a glow it could not see past. Some versions go further and let the constants of nature come to rest at different values in different regions. The strengths of the forces, the masses of the particles, even the number of dimensions that stay large, might vary from patch to patch. In most of them, chemistry, as you know, it would never begin, and nobody would be lying awake there to notice the difference. Now the part that matters more than the picture. None of this has been observed, and it is possible that none of it ever can be. Those other regions, if they are there at all, are carried off by space that stretches faster than any signal can cross. No light leaves them for us, and nothing of ours will ever arrive there. A few researchers have looked for the one mark such a scheme might leave behind, a place where a neighboring region once touched ours. A contact like that would print a faint round patch on the oldest light, a circle of very slightly altered temperature. Careful searches have swept the whole sky, and nothing convincing has ever turned up. That is not a refutation, and it is not a confirmation, and holding those two apart is most of what this science asks of you. So the question has two answers, and they sit at very different depths. The shallow one is close to certain. More space, more galaxies, more of the same, continuing well past the last thing any instrument can reach. The deep one is a possibility with mathematics behind it and no measurement underneath it. It may be true and permanently unproven, which is an uncomfortable thing for a science to carry, and it is carried anyway at a careful distance. Some cosmologists would rather not use the word universe for those other regions, since the word was meant to mean everything there is. Others use it and shrug, and the argument is partly about language and partly about what should count as knowing. The shape of that admission is easier to rest inside than it first appears. You're not being kept from anything by a wall or a lock or a decision taken about you. The limit is made of time and distance and the finite speed of light, which are the gentlest limits there are. Whatever lies past the last galaxy anyone can name is doing what such things do, glowing and cooling and drifting, with no need of your confirmation. And the part of it that will never reach you was never yours to lose. What you do have is a sphere, sized exactly by the time available, and tonight you are lying at the center of it. That is a stranger thing to be than it sounds, and it is worth one slow look before you go under. The sphere you can see is centered on you, and that is not a figure of speech. Light has been arriving from every direction for as long as you have existed, and before that toward the place where you would one day be. Draw the boundary around everything that has had time to reach this room, and the shape you get is a sphere with you in the middle. Its radius is about 46.5 billion light-years, opened out by expansion from a journey lasting 13.8 billion years. Move 10 paces to the left, and the whole enormous sphere moves 10 paces with you. At one far edge, a thin new sliver of universe comes into view, and at the opposite edge, an equally thin sliver quietly drops out. Those amounts are absurdly small compared with the whole, but they are real, and they belong to the walk you took. Someone asleep in the next room has a sphere of their own, offset by the width of a wall. Nearly all of it is your sphere as well, but not quite all of it, and neither of you could ever check the difference. Now step outward, much further than a wall. A galaxy 30 billion light-years from here has a sphere the same size as yours centered on itself. Roughly half of what it can see lies inside your sphere, and the other half lies outside, in regions you will never observe. Its far edge takes in objects that are hopelessly beyond your reach, and yours takes in objects hopelessly beyond its own. Neither of you is nearer to the middle of anything, because the arrangement repeats itself wherever you choose to put the observer. And if anything there ever looks back this way, it sees our region as it was long ago, a young and formless place still busy assembling itself. That is the whole answer to the old question about where the center of the universe is. Every observer sits at the center of what they can see, and no observer sits at the center of what there is. Those two statements sound almost the same and mean very different things, and the difference is the point. On a still night in fog, you stand inside a circle of visibility with a soft rim. The rim moves when you move. It keeps you at its middle, and it belongs to the fog in your eyes rather than to the field. Walk toward it for an hour, and you will not arrive, because there is nothing there to arrive at. The horizon of the universe behaves in that same manner, though it is built out of the age of light rather than water in the air. The oldest light you can detect left a shell of matter surrounding your position, all of it at very nearly one distance. That shell belongs to you and to no one else. The matter in it did not stay where it was, and it did not stay hot. It has had 13.8 billion years to cool and to gather, to make stars and planets and whatever else it managed to make. If anyone is out there now, their own oldest light comes from a shell centered on them, and our region sits far out near its rim. To them, the ancient glow arrives from the direction of us, and from every other direction just as evenly. You can carry the chain outward as far as patience allows. Every point has a sphere. Every sphere overlaps its neighbors, and the overlapping continues for as far as the universe continues. Whatever lies hidden from you tonight falls inside some other sphere, and the owner of that sphere may sit comfortably inside yours. So the unseen is not cut off from the seen. It is only handed along one overlapping circle at a time. There is no last sphere, no outermost observer looking back inward at the rest, nothing that would count as the rim of the whole. Whether space closes gently on itself or runs on without end, this local picture stays exactly the same in either case. Being at the center is therefore nothing to feel proud of, and nothing to feel small about either. It is simply what it is like to be somewhere in a universe where light needs time to cross a distance. The privilege, if there is one, is not position but presence. You are here, and light gathered from an enormous volume happens to be converging on the exact place where you are lying. Some of it set out before the sun existed, before the earth had finished gathering, before anything on this planet had eyes to be closed. It has crossed a distance you cannot really picture in order to end at the back of your eyelids tonight. You do not have to stay awake to receive any of it. The arriving does not pause while you sleep, and the sphere holds its shape around you either way. By morning it will be very slightly wider, because light from a little farther out will have had time to land. It grows more slowly than you might wish, and there are things it will never gather in. That is a matter for later, and it can wait until later. For now the boundary sits quietly around you at its unimaginable distance, holding steady while you settle. and everyone else lies at the middle of their own, in every direction at once, each of them equally central, each of them equally far from any edge that matters. There is a difference between what nobody knows tonight and what nobody will ever know. The first kind of not knowing is ordinary, and it is patient, and it usually comes to an end. It waits for a better instrument, a longer exposure, a colder detector on a quieter mountain. Most of what we cannot yet explain about the universe belongs to that gentle category, unfinished rather than forbidden. A smaller set of questions belongs to the other one. Those questions are not blocked by our eyes, or by our engineering, or by our funding. They are blocked by the shape of space and time themselves, which no lens can be built large enough to reach around. A larger mirror gathers more light, and that is all a larger mirror does. It cannot gather light that will never arrive. Because the expansion of space is speeding up, there is a distance beyond which anything happening tonight will stay unseen by you forever. The space in between stretches faster than the light can cross it, and the gap keeps widening, and the light keeps falling behind. Waiting does not help, not for 1 billion years, not for 1 trillion. So the sky carries 2 boundaries rather than one, and the inner one is the stranger of the 2. The outer boundary tells you how far light has managed to come so far. The inner one tells you how far anything sending light tonight can ever reach you, and it sits well inside the other. Between them float galaxies whose distant past you can study in fine detail, and whose present you can never be told anything about. There is a second kind of permanence, and it is not concealment but erasure. Some information is not hidden somewhere far away, waiting to be found by someone more patient. It is simply gone, smoothed out of existence by the early history of the universe itself. If the very young cosmos passed through a brief episode of enormous stretching, as the evidence suggests, then whatever texture it carried before was diluted almost perfectly away. Stretching a wrinkled sheet until it is 1,000 times wider does not hide the wrinkles, it removes them. You cannot recover a pattern that no longer exists anywhere, in any form for anyone. Other limits look permanent and may not be. For the first few 100,000 years the universe was opaque, and light could not travel freely through it. That would seem to close the door on everything earlier. But neutrinos and gravitational waves are not stopped by that fog, as we noted earlier, and patient work on both continues. Honesty means admitting that some limits we assume are final may turn out to be merely difficult. Then there is the quietest limit of all, and it comes from having only one universe available to look at. On the very largest scales, there are only a few independent patches of sky, and you cannot go and fetch more of them. When you measure something that exists in only a handful of copies, your uncertainty has a floor beneath which no instrument can take you. A perfect telescope run by perfect people under perfect conditions would return the same irreducible error. Astronomers gave this a plain and slightly melancholy name, cosmic variance. It means the sky itself is the sample, and the sample is one. There was no rehearsal, and there is no control group, and the experiment does not run a second time. Almost every other science can repeat itself, and cosmology cannot, and that is a permanent condition rather than a temporary embarrassment. Some questions may never even be phrased in a way that lets the sky answer them. Why the constants of nature hold the values they hold, why there is a universe here to be measured at all, these are honest questions with no obvious experiment attached to them. Someone may find one, and someone may not, and nobody can promise you either outcome. The universe is under no obligation to be fully knowable from the inside. We are inside it, and we cannot step outside to check our working. The strangest limit of all points forward rather than backward. The evidence we currently hold is not permanent either. Given long enough, and the time scale here runs to something like 100 billion years, the galaxies beyond our own small group will have receded past all seeing. The oldest light will have stretched until it is too faint and too cold for any detector to register at all. That future sky was described earlier tonight, and its lesson returns here in a quieter form. A sky can lose its own evidence entirely, leaving careful observers to reason well toward a conclusion that is wrong. The same caution belongs to us, and that is the only reason for saying it again. We are also reading a sky that has already thrown some of its pages away, and there is no way to count the missing ones. This is not a defeat, and it does not need to trouble you tonight. A science strong enough to mark its own boundary and say plainly that we cannot get past this is a serious and trustworthy thing. Most ways of explaining the world never manage to say that sentence even once. The universe is not withholding anything from you out of unkindness. It is only larger than the light it has had time to send, and older than the record it has managed to keep. You can lie there knowing the shape of the gap without needing to fill it in. The light that did reach you is still coming in, and the last part of the night belongs to it. Right now, in the dark air of the room you're lying in, the oldest light in the universe is passing through. It is faint and cold and completely silent, and there is a great deal of it. In every small pocket of space around your bed, there are a few hundred of those ancient particles of light, arriving from every direction at once. They set out when the universe first became clear, and they have been traveling ever since, and tonight some of them finish against your wall. Some of them finish against you. That light carries a temperature a little under 3 degrees above the coldest possible cold, spread almost evenly across the whole sky. It is the last warmth of a time when everything everywhere was glowing at once. It has been falling on this world since long before there were rooms for it to fall into, and it has never once stopped. Nothing about any of it requires your attention. It has been happening every night of your life, and every night before your life in this room and in every room. The light does not know that you are here, and it arrives anyway. Think back to the darkness you can see through any window. It looked empty, and it is not empty, and it is not finished. Between the stars there are directions whose light is still on its way, having set out long ago and not yet crossed the distance. The blackness is a timetable rather than a void. The boundary we drifted toward all evening was never a barrier. Nothing stands at that distance, and nothing is being held back, and no one out there feels any limit at all. It is only the reach of light in the time available, close to 13.8 billion years of steady traveling, because space itself kept stretching while that light was in transit. The places it started from lie much farther out now, around 46.5 billion light years away. Both of those figures are true, and they have never been in conflict. Every observer anywhere has a sphere like yours, centered on themselves, the same size, filled with different things. Their sky is as full as yours, and no fuller and no closer to any edge. There is no privileged place, and there is no rim, and nobody is standing at the edge of anything. Among the light coming in tonight, there are pieces that left their galaxies before the sun had formed, before the earth had gathered itself out of dust. They crossed all of that emptiness without touching anything at all, and then the journey simply ended here, on an ordinary world, on an ordinary night. That is not a rare event, and it is happening constantly, and it will go on happening while you sleep. The sphere around you is still opening tonight a little, in the slow way that such things happen. Some of the newly arrived light will land on a mountaintop mirror and be recorded and become a measurement and change what we know by a small amount. Most of it will land on ocean, on rock, on rooftops, on the closed lids of sleeping people, and simply be absorbed. That is the ordinary fate of nearly all the light there has ever been. We spent the evening walking out toward the limit of what can be seen, and then admitting that we cannot walk any further. Whatever lies past, it is not lost, and it is not hidden on purpose, and it is certainly not empty. It is only out of reach, which is a much softer thing than absent. You do not have to hold any of this in your mind. It was never a problem to solve, and there is nothing here that needs finishing tonight. The parts we may never learn will still be unlearned in the morning patiently, without any harm coming from it. The parts we do know will still be there too, unchanged by whether anyone is awake to think about them. Let your breathing get slower now, in its own time, without being managed. Let the weight of your body settle a little further down into the bed. The room is small, and the sphere around it is very large, and both of those facts are comfortable. You are at the exact center of everything you can see, which is a quiet kind of importance, and it costs nothing to hold. Your attention can loosen now and drift and go wherever it would like to go. If it wanders out past the stars, that is fine, and if it stays here in the room, that is fine as well. There is nothing you're supposed to do with any of this before morning. The oldest light will keep passing through the room, whether you're following it or not. Far away at distances that mean nothing at all to a body in a bed, galaxies are turning slowly through their own long nights. Their light is already on the way, and it will not arrive for an immense stretch of time, and nothing needs to be done about that. When you wake, a little more of it will have reached the world. None of it will be lost by your sleeping through the arrival. The universe has been sending without pause for 13.8 billion years. It will keep on sending through the rest of tonight. Rest now and let the light keep arriving without you. Good night from the quiet middle of your own small sphere of stars.